Well, we've said a bit about the origin of the planet and the oceans, which cover most of it. Remember, about 70% of our planet is covered by water, and most of that is in the ocean. And remember, more than 97% of the actual water, which is at the surface of the Earth, is in the ocean. So that's where the water is, and that's where the beginning of what we call the hydrologic cycle is. You know, as the water comes out of the ocean, okay, comes up into the atmosphere and comes back to the land. So let's take a brief look at that. And it's a very, very simple diagram. Notice that normally when I'm doing a cross-section, say, of a piece of land, I put these little hatchet marks in, indicating that we're just kind of slicing down through the coast. Okay. And when I put a wavy blue surface, that indicates the surface of the ocean over here. Here we have the ocean. Okay. So this could be a continent over here. Okay. And we have an ocean over there. And up above us, we have the atmosphere. And don't forget that most of the energy which drives the processes that we're concerned about at the surface of the Earth is going to be coming from the sun. So let me put the sun up here. And remember, radiation is coming from the sun. And that's what heats up the surface of the water here, causing evaporation to take place. And notice, it's very interesting, if that water simply drifted out into space, remember that about a meter of water on the average, more in, of course, in tropical areas, less in the polar regions, but on the average, about a meter of water is evaporated away from the surface of the oceans every year. Okay? So if the water wasn't returned in some way or another, either directly by storms dropping the water right back into the ocean again, you know, or transporting it to land where it comes back again, the oceans would keep getting shallower and shallower and shallower. It's been calculated that after about 3,000 years, it would all be gone. Well, fortunately, we have something else. We have gravity, okay, which pulls it back to the Earth. So let me just put here, pulling down, the big G, gravity. Okay, remember we're going to be talking about gravity a lot in this course. Okay, well, the hydrologic cycle involves the water coming out of the ocean by evaporation. Okay. And an important thing to remember about the atmosphere is that the lower part of the atmosphere, what we call the troposphere, is one in which the temperature decreases as you go up. So as this water vapor rises, it tends to condense. It condenses into little water droplets, which form eventually into clouds. And then some of that is going to come right back into the ocean again. So we may have clouds forming. Okay, which will result in precipitation. It goes back into the ocean. Well, if that's all that happened, it would be very dry on land. But of course it doesn't. The winds in the atmosphere move the clouds over the land, and the precipitation takes place there. Okay, then that water will have to, in one way or another, it's going to have to return to the oceans. Now, it gets stopped in a couple of other reservoirs. We can sometimes think of the ocean as being the biggest reservoir, but also some of it is collected on polar ice caps, for example, in Antarctica and in Greenland. Okay, and this is a big issue at the present time as to how fast they're melting and so forth. Some of it is collected as groundwater, where in general it moves very, very slowly. Not always. Sometimes we have underground rivers, but usually it's just kind of seeping through the rocks and the soil. So we can consider that to be another reservoir. And the rest of it, the very active part of the water, interestingly enough, the streams which are flowing down here, coming back in, which do most of the geological work actually on land, are actually a very, very small part of the total amount of water, but they're very active. They're very active on land here, so they're extremely important from the point of view of changing the topography, changing the shape of the landscape over here. That water, though, will eventually come back into the ocean, okay, and it will carry with it sediments, okay, which will then be distributed out here, and nutrients which help the life in the ocean, and sediments which pile up on the ocean floor. In fact, in a little bit, we'll be looking at what we can learn from those sediments, from the things that are carried down from land into the ocean and accumulate at in the ocean. We'll also be looking at, we'll continue our rock surface here down under the ocean, and we'll be looking at the ocean basins down there and how they formed and what the interaction between them and the oceans are. But now I want to say a bit about the past, as far as not going back billions of years now, but going back thousands of years, to what do we know about the oceans now, and how did we get there, and what impelled people to go out onto that water, which again can be a very dangerous place. So let's take a look at the history of exploration a little bit now, as people began to realize that they could build boats and they could move out into the ocean. And again, in terms of the astronomy that we talked about previously, they sometimes had a pretty good idea of where they were, or at least what direction they were going. So people learned about navigation, about getting around on the oceans. And for a long time, they probably just crept along the shore, where there are what we call landmarks. They could see parts of the land and they could recognize them. But eventually, they learned to be able to navigate out on the open ocean. Now, among the first people that really discovered how to travel very, very long distances on the open ocean without any landmarks to help them at all were the Polynesians, the people that spread out across the Pacific Ocean. Okay. There's been a lot of controversy about just where they came from originally. Currently, we think they came from Southeast Asia. Okay. They built their great boats and with outrigger canoes, some of them very, very long and very, very large, and they went out to the islands which they populated. They went out to Tahiti and to Samoa, okay, and to New Zealand, and eventually, established societies on these islands, which again developed in very, very interesting ways, because they were island communities, and they made most of their living from the ocean, from what they got out of the ocean. Okay. Well, they were probably the first great navigators, the Polynesians, the people going out across the oceans. Coming further up into more modern times, the people in the Mediterranean area were very interested in trade, for example, and so we know quite a bit about the trading routes of the ancient Greeks and the Phoenicians, for example. Okay, and it was a Greek scholar, Eratosthenes, okay, who was actually the chief librarian of the great library at Alexandria, and you might want to take a look at what our book says about that in the second chapter, for example. And he was the first person making use of simple principles of geometry, okay, and being able to measure angles and distances. He was the first person, as far as we know, remember that's something we always have to say about these discoveries, as far as we know, the first one to do something, okay, to find out just what the circumference of the Earth was, okay. He made calculations, okay, over here in North Africa as a result of the angle of the sun at different times of the year and the distance between different locations. He was able to figure out, just how big the Earth would actually be, okay, making some, fairly simple assumptions, sort of one of which would be, for example, that the rays coming in from the sun are coming in essentially parallel. Okay. It turns out that most of his assumptions were right. Okay, the calculations that he did were very refined for their time, certainly, and the result was that he came up with a number which seems to be very, very close to the number that we have today. We have a circumference of the Earth as being about 25,000 miles, or about 40,000 kilometers. Okay, and he came up with numbers that were very, very close to that. Now, notice that one of the problems here is one of the problems we're going to have throughout the course, and that is the type of units that you use. He was measuring according to the ancient Greek method of measuring things, and we don't use that today. So we have to kind of convert, his numbers into our numbers today. And this is approximate, but basically, by finding the ruins of the ancient Greek stadiums, and this is interestingly enough where the ancient Olympics come in. If you look at a Greek Olympic stadium from that era, 2,000 years ago, okay, you have a pretty good idea of what their major unit of length was, what they call the stadion, okay, and that was from the inside of the stadium to the outside. Okay, and the fastest person in the Hellenic world, you know, they got the wreath on their head and the crown and lots of money as a result of this, you know, was the one who could run the fastest right through the stadium. Well, we can go to those ruins now, we can measure that and see how far it was, you know, in terms of meters or in terms of feet. Unfortunately, they didn't build all their stadiums the same size, so we don't know for sure, but we have a pretty good idea, okay? And, you know, taking that into consideration, Eratosthenes did a remarkable job. Okay, and again, you can see in the book there is a diagram indicating, you know, just how he managed to do that. Okay, well, the next great expeditions that we know about were the ones that the Chinese did in the Ming Dynasty back in the 1400s, when they made some remarkable voyages on their remarkable vessels, far ahead as far as the technology was concerned of what the people in Western Europe had at that time. And they sailed out down into Southeast Asia, along the south coast of Asia, all the way down to the east coast of Africa, and they mapped these areas. Now, it's interesting to note that they didn't go for conquest, they didn't go for trade, they went to give away, you know, presents to the people, okay? So this was sort of an indication to the people living in those areas, you know, that China doesn't need anything, you know, that we're not going to take anything away from you, we're just going to show you how benevolent we are, okay? This is very interesting voyages taking place there, but it didn't lead to very much, because after a while they stopped them, they had other things to do than explore the world, and so they say there wasn't much of a follow-up on it. This is sort of like Leif Erikson, remember, around 1,000 years ago, you know, who really discovered America, you might say, from the European point of view. Okay, but there was no follow-up. Nothing came of it much, except that a colony was set up in Greenland, which, interestingly enough, perished. Presumably as a result of climate change, which occurred, you know, with the onset of what we call the Little Ice Age, which is something that we'll look at a little bit later on. Whereas, in the same century that Zheng He, the Chinese explorer, made his discoveries, but towards the end of the 1400s, Columbus made his, and of course that was very important from the point of view that, you know, it was followed up on, you know, in a large way. Other voyages came out from Europe, of course, and led to significant changes, of course, in the history of the world. Okay. Another great expedition that occurred, or series of expeditions, which occurred, were those which completely circumnavigated the globe. The ancient Greeks had figured out how big the globe is, okay, but it wasn't until, as far as we know again, until the 1500s, that first Magellan and then Sir Francis Drake sailed all the way around the world. Okay. By the way, one of the things that Columbus discovered inadvertently, since he did travel a considerable distance across the Pacific Ocean, and they were using the compass, which had originally been, you know, developed in China and eventually came to Europe, he discovered what we call the magnetic declination. That is, that the magnetic pole is not the same as the actual geographical North Pole. Because as he went further and further across the Atlantic Ocean, his compass needle kept pointing in a different direction, you know, from the direction to the North Star, which was quite startling to people in that time. Now, again, we'll say more about gravity and magnetism, these basic physical principles, a little bit later, because they're very important to discoveries that were made about, you know, just how the Earth was built, so to speak. Well, going on into the 1700s, another great expedition was that, or several of them actually, was always of James Cook, coming out of England. And you'll find Cook's name all over the Pacific Ocean. There's Cook Inlet up in Alaska. There are the Cook Islands, you know, in the South Pacific Ocean. There's Cook Strait between, you know, the North and South Islands of New Zealand, for example. So he made some great voyages of discovery, you know, all across the Pacific Ocean. And he was one of the first navigators to be able to pin down his longitude pretty well. As we've mentioned, using astronomy, you have a pretty good idea of how far north and south you are, latitude. But how far are you east and west? That was always, very, very difficult to calculate until the discovery of, or actually the invention of, the marine chronometer in the 1700s, where you have very good timekeeping, which enables you to find out just how far you are, east or west, of your starting point. This, as I say, came just in time for Cook's voyages, so he was probably the first of these navigators who was able to put on the map pretty precisely both where his latitude and his longitude were. Well, coming on up into the 1800s, we have a great American expedition that doesn't receive an awful lot of fame, and that is what we call the American Exploring Expedition back in the 1840s. And it was led by Charles Wilkes. And they sailed down across the Pacific and made a number of discoveries there. But most important, they found their way all the way to the coast of Antarctica. Now, they weren't the first to arrive at the coast of Antarctica. There have been several other voyages which had touched on some of the northernmost parts of that continent, but they didn't really know how big it was. They only saw a little bit of it. What Wilkes did was he sailed along the coast, for a long, long distance until he realized that this had to be a major land mass. It was probably not just an island, it was probably a continent. So from the point of view of realizing that Antarctica was another continent, beyond the known continents, and the only one, remember, which was, unsettled, before the arrival of the Europeans, this was really a great discovery. Yeah. Towards the end of the 1800s, at the other end of the Earth, another expedition, which was extremely important, was that of Fridtjof Nansen, the Norwegian, who sailed into the Arctic Ocean in a vessel which he had designed himself, the first real icebreaker designed from scratch, you might say, and purposely got himself frozen into the ice and allowed his little ship to drift with the ice, and made the first real oceanographic discoveries, in the Arctic Ocean. They also tried to reach the North Pole. They hopped out of the ship, went across the ice, but unfortunately there were big gaps, in the ice, and they didn't make that. And of course, the North Pole wasn't reached until some time later. But they were the first to really make careful investigation of the sea ice and of icebergs and of the water below it. Nansen invented what we call the Nansen bottle, which we still have today. We have improvements on it, of course, but essentially, how do you find out what the water is like at depth? If you just drop a pail down and pull it up, it's going to get mixed with the water on the way up. So we invented a bottle which you drop down, it opens up, the water goes into it, it closes, and then you bring it up, and it gives you undisturbed the water from a particular depth. And as I say, he had a number of other major inventions of that type. So Nansen's expedition is extremely important. The first really knowledge that we had about the far north, about what was going on up there, both the oceans and the atmosphere. And in fact, his discoveries led to a whole series of other discoveries which were made. Well, going on into the 1900s, something we're going to be talking about next has to do partly with the oceans and partly with the land. And we really didn't know what the answer to these questions was until we were able to get down into actually the bottom of the ocean. So oceanography has a big part to play in it, and that is the theory of continental drift by Alfred Wegener, which eventually led to the current theory of what we call plate tectonics. And this is going to be the topic which we're going to be covering in the next time we get together, which really tells us about how did the ocean basins form, and what are they doing, and what is the activity down there, and how is it that we have the current configuration of the continents and the oceans. How did they essentially get in that configuration? So there's a lot more that we're going to be talking about that has to do with some of these expeditions of the past, but this is kind of a brief resume, a brief indication of just what people have been doing over the last few thousand years to find out about what's in the ocean. Thank you.